Hello students, welcome to the lecture series of TCMT. Today in this video we are going to discuss about the topic commutation in DC generators. So commutation is the process of reversal of current in brushes and commutators segments. Means that the change that takes place in the winding element during the period of a short circuit by a brush. In other words, we can define commutation as reversal of current in the armature winding by means of commutator segment bar and carbon brushes is known as commutation process. So current flows in one direction when number of conductors Z are in N pole, that is north pole, and in opposite direction when the same number of conductors are under S pole. So the conductors are rotating, the armature is rotating, the conductors are placed in the armature as a winding. So when it is rotating, it is crossing north pole and south pole. When it is crossing north pole, the current direction of conductor is in one direction. The same conductors which are crossing the south pole, the direction will be reversed. So while conductors entering from south pole to north pole, current in conductors are reversed, or south pole to north pole, it is again reversed. So this reversal current takes place along with the magnetic neutral axis, which is the brush axis. MNA, which is magnetic neutral axis, which is also called brush axis. The process by which current in the short circuit coil is reversed while it crosses the MNA is called the commutation process. So here in this circuit diagram we are illustrating how the commutation takes place in generators. So we are considering three different coils, red, yellow, blue here, right? In the case 1, prior to short circuit case, that is the brush is now in contact with the one segment, that is B segment alone. For example, total 40 amps of current. So that 40 amps is flowing through the yellow winding and blue winding. Then this 20 amps and 20 amps will be 40 amps will be flowing to the brush. Now the case 2 is 25% of brush is moved to the nearby segment A from B, whereas 75% of brush is 75% of the portion of brush is with the existing segment B. In this case also the current is same, right? The 40 amps is there, but the distribution of current, see that 30 amps, that is 20 amps from red, and 10 amps is diverted here, and remaining 10 amps is diverted to Y coil, yellow coil. So this 10 amps, and already we have 20 amps in the blue, so this 30, total 40 will be flowing through this brush. So the 40 amps of current is unchanged, but the current distribution in windings are changed, and you have to notice the directions. Next, the third case, we are considering 50% of the portion is with the commutator segment A, and remaining 50 is with the existing commutator segment B. So in that case also the 40 amps, but in Y winding now it is zero current. Initially it was 20 and then 10, now it is 0, and from the red winding it is 20 amps, and from the blue winding already 20 amps. So those 20 plus 20 is equal to 40 amps is flowing through the brush. Now the next case, 25 percentage is with the existing B segment, 75 percentage of brush is with the A segment. In that case, 20 amps from the R winding, the 20 amps from B winding is split into two, that is 10 amps, 10 amps, and then 10 amps is flowing through the Y winding. Here you could see the current reversal takes place in yellow winding. So when the brush is moving from one segment to other segment, current reversal takes place in conductors. That process is commutation. So this 30, this 10, 40, 40 ampere is flowing. See that from case 1 to case 4, this yellow winding current direction is now changed. That happens due to when your press is moving from one segment to other segment, the current reversal takes place in the armature conductors. So when it is full portion of your brush is moving from B segment to A segment, total 20 amps which was initially there with the yellow winding is reversed. So this is called the commutation. And there may be the spark of 5 ampere or some amount of current happen during poor commutation. So if that reversal is not proper, that we call it as poor commutation. In that case, some amount of current will be taking this path, that is the spark. It occurs as a spark. So we have to improve the commutation. So for example, here in that 40 amps, maybe 5 ampere is flowing as a spark. So for ideal commutation, this is plus to minus, that is reversal of current is smooth. In a power commutation, it is not linear. There may be a slight spark will be there with the power commutation. So we are trying to have this type of ideal commutation, that is we are trying to have this linear change. Current reversal should be linear. So to improve the commutation, we can have different methods, that is resistant commutation and EMF commutation, two different methods. In resistance commutation, you know we are changing the resistance of brushes, low resistance copper brush into a high resistance carbon brush. We are replacing the low resistance copper brush into high resistance carbon brush. So this will show you the current path, the C, B, and then brush. In the second path will be your short circuited coil B, A, and brush. If copper brush, the current will follow the first path. If carbon brush, current will follow the second path. So if carbon brush and copper brush, there is a difference in resistance, and so the current path will be changing. So resistance computation will give you different advantages and disadvantages. It has some degree of self lubrication is there, and polishing to the commutator. Damage during sparking is less compared to the carbon brushes, whereas in carbon brush the contact drop will be high than the carbon brush 2 volt. Size of commutator is larger than using copper brush. So for efficient heat dissipation, we use the carbon brush. And EMF commutation is done with the interpoles. So interpoles are used for armature reaction as well, right? So the reactance voltage E is produced by these interpoles, which neutralizes the reactance voltage produced during commutation is neutralized by the interpoles, since reversing EMF is produced since it is short circuited coil under commutation. So the reverse voltage is out of phase to that of reactance voltage. So we have interpoles for producing that reverse voltage, and brushes are forward shifted to bring the short circuited coil under the influence of next pole of opposite polarity. uh, by doing this way also we can neutralize the reactance voltage. Yes, thank you.